Let's look at the concept of average velocity in a fairly concrete situation. Suppose that a bus is traveling due east on a straight road, and that after x seconds it's traveled a distance of y meters, where y is given as some function of x. Let's say that for the first 5 seconds that it travels, this function is given by 2 times x squared. So this might not be true forever, but at least when x is between 0 and 5 seconds. Let's say that this holds. So for example, after 3 seconds, the total distance traveled will be f of 3, which is 2 times 3 squared, or 18 meters. And after 5 seconds, the total distance traveled would be 2 times 5 squared, or 50 meters. Now suppose we wanted to figure out the average velocity of the bus over some time period, say between x naught seconds and x seconds. The way we'd do this is we would have to figure out how far the bus had traveled between these two times, and then divide it by the amount of time elapsed. So to find out how far it had traveled, we would find its positions at the two different times, f of x and f of x naught, and we'd subtract them. And of course the amount of time elapsed would be x minus x naught. Now a symbol which is sometimes used to represent a change is the capital Greek letter delta. So another way of writing this would be delta x, representing the amount of time, divided into delta y, which is the total amount of distance. So distance divided by time will be the average rate. Since delta x represents x minus x naught, we could rewrite this to say that x is the same as x naught plus delta x. That gives us this formula here for average velocity. F of x plus x naught plus delta x minus f of x naught divided by delta x. Just another way to write the same formula. So let's continue this by calculating the average velocity over a few different time intervals. In the first situation, x naught is going to be 3 seconds and x is going to be 4 seconds. So the amount of time elapsed is delta x, which is x minus x naught, which is 1 second. Now to find the amount of distance traveled, delta y, we need to find its position at time x, or time 4, subtract its position at time 3. So its position at time 4 is given by the formula 2x squared, or 2 times 4 squared. Position at time 3 is f of 3, or 2 times 3 squared. Twice 4 squared is 32 meters. Twice 3 squared, we already calculated, was 18 meters. So the total amount of distance traveled will be 14 meters. And then the average velocity, delta y over delta x, is 14 meters in 1 second, or 14 meters per second. Let's look at the second situation, when x naught is 3 and x equals 3.1. So the time elapsed, delta x, is 3.1 minus 3, or 1/10 of a second. And the distance traveled, delta y, will be the position after 3.1 seconds minus the position at 3 seconds. So 2 times 3.1 squared minus 2 times 3 squared. And if you plug that into your calculator, you should get 1.22 meters. So in that 1/10 of a second, the bus has moved 1.22 meters. So the average velocity, delta y over delta x, will be 1.22 meters traveled in 1/10 of a second, which is 12.2 meters per second. In part C, we're working over an even shorter time interval, between 3 seconds and 3.01 seconds. So the time elapsed this time is only 1/100th of a second. The distance traveled will be f of 3.01 minus f of 3, which is twice 3.01 squared minus twice 3 squared, or about 0.1202 meters, so about 12 centimeters. The average velocity will be delta y divided by delta x, or 0.1202 meters divided by 0.01 seconds, or about 12.02 meters per second.